Hello everyone, welcome to today's class. Today we are going to discuss about interval notations and inequalities. So these are the four topics we discuss. What is inequalities? Representing inequalities on a number line, converting inequalities to interval notation, then combining interval notation using union and intersection symbols. Okay, first we talk about inequalities. So what are inequalities? So see, the definition says an inequality is a mathematical statement that shows the relationship between two values, telling us which is greater, smaller or equal compared to the other. So see the first example here. X is greater than 3. This is the greater than symbol. See, this symbol means it's a greater than. So this left side, with the value in the left side is greater than the value in right side. That's what it means. So here x is greater than 3 means x is greater than 3. I mean, what are the value of x, we don't know, but the only thing is we know is x is greater than 3. That only we know. X should not be less than 3. X must be 4, 5, 6, 7, 8, 9, 10, go any number to infinity, but it should not be less than 3. So 2, 1, 0, minus 1, no, it's not be possible. That's the meaning of this expression. Second one, see, x is less than or equal to 5. That means x means less than or equal. Less than or equal means x should be 5 and less than 5. Here what the difference is, x is greater than 3 means the 3 is not included. So all the values above 3, which 3 is not included, 3 is excluded. But here x is less than 5 means x is less than 5 including 5. That means the values together with 5, 4, 2, 1, 0, less than, minus 1, like that it will go to the infinity, negative infinity. So this is the main difference between these two symbols. So we will next we are going to see details about these symbols and the meaning of the symbols. Okay, so we use some symbols to represent the inequality. So these are the symbols. Let me explain. The first one is less than. We already discussed before. A less than is, this symbol is this, a less than. So the value left side is less than the value of right side. This is the less than. Example, the x is less than 5 means x has all the value which is less than 5. See, 5 is not included because this is only a less than symbol. So 5 is not included. So the second one is less than or equal to. So we will write like this, less than or equal to, a line here in the below to the less than side. So less than or equal to means including that value. So I will write an example here. X is less than or equal to 5. That means x is less than or equal to 5 means both including 5. Here 5 is not included. It will be counted as 4, 3, 2, 1, 0, like that. But here 5, 4, 2, 1, 0, like that. So 5 is included. That's the main difference between less than and less than or equal to symbol. These two symbol, this is the main difference. So let's talk about greater than. Greater than means this is the one, greater than. So this value is greater than compared to the right side value. Example, see, same, x is greater than 5. That means x has the value greater than 5. So 6, 7, 8, 9, like that. So see, 5 is not included. So the symbol is greater than or equal to. Same like less than or equal to. What does mean? The value including the all the values including that value. So the x is greater than or equal to 5 means 5 also included, 5, 6, 7, 8 until infinity. So this is mean greater than or equal to. So keep in mind these four differences, different symbols: less than or equal to, greater than or equal to. So these are the major differences. Keep in mind, we will use this on the further computations. Okay, so let's discuss representing inequalities on a number line. Okay, how to represent an inequality equation on a number line. So the first two important point is use open circle. See, this is open circle. Inside the circle is blank. So or use open circle for when we using less than or greater than, which is not included. Which the value is not included. You have to use open circle. For example, here see x is greater than 2. X is greater than 2 means this 2 is not included. Okay, as we discussed before, when only a greater than symbol, this 2 is not included. So how we represent this in a number line? See, use open circle and shade to the right. See, this is how we do that. So x is greater than 2. So this is the 2. We will write x is greater than 2. So this 2, okay, here we use an open circle and we can shade all the values to the right side. Okay, otherwise we can do like this also, using an arrow mark. Using a straight arrow mark, you can write all, it means all the values to the right of the 2, but a 2 is not included because we are using here an open circle. Okay, and next example, see, use closed circle. Closed circle, when we are using closed circle, is less than or equal to or greater than or equal to, which means included. That value includes. Okay, for example, here x less than or equal to -1. That means x less than -1, less than or equal to -1, that is -1 also included. So we use a closed circle. So here's this is the example here, x less than or equal to -1. So this is the -1 here. So we use here a closed circle. A closed circle means this -1 value also included. Then you have to shade all the values on the left side. Okay, so this means this -1 also includes. So this means x less than or equal to, less than and equal to. So this is what we use. This is how we represent inequalities in the number line. So keep in mind, when we use open circle, which the value is not included, x for example greater than or less than symbol. When we use a closed circle, when which the value which is included, so we example is less than or equal to, greater than or equal to. So exclude and include. Okay, so third one is converting inequalities to interval notation. So before that, let's see the definition of an interval notation. See, an interval notation is a compact way to write all possible solutions of an inequality using brackets. So in inequalities, we are using less than, greater than, less than or greater than, equal to symbols are there. So, but in the interval notation, we are only using brackets. There are two types of brackets we are using. One is this normal bracket, next it is a square bracket. Okay, I will explain you what's the difference when we need to use both brackets. Okay, so let's go to the first example to how to convert inequalities to interval notation. See here the first one is x greater than 3. X greater than 3, what is the meaning? All the numbers above 3 is not included because there is no equal symbol here. So x above 3, which is 3, is not included. So we will write an interval notation like this. In above 3 means what is the end point? There is no end point. It's continuously going. So we use infinity symbol as the right hand side. So 3 comma infinity. So that means 3, the numbers between 3 to infinity. So here 3 is not included. That's why we use a normal bracket here. See, a normal bracket here because 3 is not included. In the right hand side, infinity. So infinity also not included because why? Infinity is not a fixed point, or this is not an end point. Infinity means is continuously going to the unlimited space. So at this time, don't think too much about infinity because infinity is a very complex topic. So what is infinity is very difficult to define also. Because infinity means, just keep in mind, infinity means there is continuously going to the end point, but there is no end point here. So that's why always keep in mind infinity. This is going to positive infinity. That means there's two infinities are there. On the left hand side, negative infinity also there. We are going -1, -2, -3, -4, so going to the negative infinity. So right hand side to positive infinity. So 1, 2, 3 is going to the positive infinity. So here x is greater than +3. That means x is greater than all the values above 3. So we use positive infinity here. So all the numbers greater than 3, which is 3 is not included. That's why we use open, this is an open bracket here. Okay, so then next one is x greater than or equal to 3. That means here 3 is included. So we use here x, this inequality, there is equal symbol. So x includes the value 3. So we close a close bracket. So that means 3 is also included. We can square bracket or close bracket, we can say that. So here 3 comma infinity. See the difference between the top, the first one and second one. The 3 is included. That's why you use here the close bracket. So comma infinity. Always use open bracket for the infinity. So all the numbers 3 and greater. So 3 is also included. That's why you use here close bracket, because here's equal symbol here. So third example, x less than 2. X less than 2 means x has all the values which is less than 2. 2 is not included because there is no equal symbol here. So when we go to interval notation, it is going to 2 to the negative infinity. So we write negative infinity first. So because it's a left hand side, so negative infinity with is open bracket. There is no, we cannot include a negative infinity in the so we use open bracket. So then 2 is also not included. So we also close an open bracket in the right side. So minus infinity to 2. In the both are open brackets. All numbers less than 2. 2 is not included. That is how we write. The next one is x less than or equal to 2. Here 2 is also included. So we use negative infinity, always open bracket, because it's going to the left hand side. The number continues to the left hand side. That means 2, 1, 0, minus 1, minus 2 is going to the left hand side. So this is why we write negative infinity here. Then 2 comma 2. 2 is because 2 is included, because it's equal to here. So we use closed bracket here. This is square bracket. So this is how this is the difference between the two symbols. All numbers up to and including 2. Okay. So the fifth one. See, this is an inequality notation. See, minus 2 less than x less than or equal to 5. What does this mean? X has the value which is less than or equal to 5 and greater than minus 2. That means x can contain the values. 5 is also included. So 5, 4, 3, 2, 1, 0, 1. Minus 2 not included. Yes, because this minus 2 is not included because there is no equal symbol here. So let's write here in as an interval notation. So minus 2 is included or not? No, not included. So minus 2. So x is lying between minus 2 and 5, which 5 is also included. So minus 2 comma 5. 5 is included in this. That's why we use close bracket here, square bracket here. Okay. So minus 2 comma 5. See, x lies between minus 2 and 5, including 5. So this is how we write interval notation for this inequality equation. Okay. And one more thing we need to keep in mind. I already explained you. Note, infinity and minus infinity always use parameter open bracket. Why? They can never be included. Infinity and minus infinity we cannot include in our equation because it's an unlimited going process. There is no end point, there is no fixed point. So always keep in mind, whenever infinity come in your left side or right side, you must use open bracket. Okay. The next topic is combining intervals. So combining intervals means if we have two separate parts of an interval, we need to combine those together to make it in a single interval. So that's what we are going to see in this section. Here we are using union and intersection symbol to combine two parts of interval. So before that, we need to see what is union and what is intersection. So let's start. What is union? So union means, see, definition says the union of two sets or interval means all the value that belongs to either one or both intervals. Think of it as a joining or combining all possible numbers of both. A simple understanding I'll tell you with an example here. See, here you can see one example. See, A. First interval notation, A is minus infinity to 2. What does that mean? Which A includes all the number less than 2. See, all the numbers less than 2. Okay, the b is, what is the b? 5 comma infinity, positive infinity in the open bracket. What is b means? B includes all the number greater than 5. So a is numbers not including 2, less than 2 to minus infinity. B is not including 5, greater than 5 to positive infinity. Okay, let's mark this in our number line. Let's see. So here first I am going to write 2 and minus negative infinity. So 2 is here. I am writing here a open bracket, open circle, and going towards negative infinity. Okay, negative infinity going towards. Then next is 5 to infinity. So also I am working here an open circle because 5 is not included. So going towards positive infinity. Okay, so these are the two parts of a intervals. So here what is mean? It is a between, there's a region between, so minus 2 and 5. This region is not included, but now we write it as a separate interval. So now we need to write these two separate interval in a together. We need to write the separate interval together. So how we will read? So we need to, the main aim is to, we need the values from minus 2 to minus infinity, and the values of 5 to infinity. So we need to combine these two. So that's why we use a union symbol. This is how a union symbol look like. Exactly look like a U. Okay, so we will write here combining A and B. So A union B. We write like this, A union B. So what is A union B? We combine these two interval. So minus infinity comma 2, the first part of the notation. A union, U symbol, see U symbol. So then 5 comma positive infinity. So this is how we write. We use union symbol to combine two separate part of a inequality. So we can write like this. So the meaning is all the values, see, all the values of this interval and this interval, two set of values are combined. Okay, this is how we combining two interval. So hope everyone understood. So finally the meaning of this entire equation is A union B is equal to minus infinity comma 2 open bracket union 5 to infinity. That means all the real values, all the real numbers except this region. This region is not included. Okay, so this region is not included. Balance all numbers are included in this interval sign. Okay, this is the meaning we need to read from this equation. Yes, this is it. Okay, let's see an example here. Here this example has an overlapping union. So let's explain what is it. See, what is overlapping union? When we take the union, combine them, there is some overlapping parts, so it will be merged. We include the values covered by both also. So I will explain you with an example here. So for this first inequalities, so first interval notation is A is equal to 1 comma 5, the numbers between 1 and 5. B is numbers between 3 and 7. See, first we write the first A. So what A is saying, 1 and 5. So 1 is not included, 5 is not included. So we plot the open circle. It's going to 5. Open circle here because 5 is also not included. Let's mark B. 3 and 7 both are not included. So 3, I write here open circle 3 here and open circle 7 here. Okay, then I am connecting this. So A is 1 to 5, then B is 3 to 5. See, there's an overlapping region here. See, both cases, this overlapping region. So this region, what we do is when we combining, what we as per the previous, what we do, 1 comma 5 union 3 comma 7. This is how we write this union symbol. But when we have a equation like these two intervals are not a separate part. I mean, it's connected. It has common region also. A union B is equal to the common region is It's called, this is common region. So the entire interval will start from 1 to 7. So the entire, so we don't need to think about this common region. Just think where the where the interval started and where the interval stopped. So this is first interval started from 1. Okay, when we write using a union, when we combine two intervals, we need to see where it started 1 and where is n 7. Okay, so we can write as a single interval. So a union b is equal to 1 comma 7. We can write like this, because this is not a way, this no need to write in a separate two interval, because why, it is combined, it's joined together. The meaning is, on a number line, it's continuous shaded line from 1 to 7. So the meaning is all numbers between 1 and 7. See, all numbers between 1 and 7. This is how we write a union b is equal to 1 comma 7 in the open bracket. This is, we can simplified form of this union. This is called overlapping union. So keep in mind how to write an overlapping union interval and the separate parts combining together. So this is the difference. Okay, so next we are going to see intersection. What is intersection? So intersection, see the symbol, it's a reverse sign of u. It's like a look like n. Let's start with the definition. An intersection of two interval means the common values. See, keep in very important point is common value. The numbers that belongs to both intervals at the same time. Okay, it's look like the opposite. So it's look like it's opposite of a union. Okay, so the symbol is look like here, this n, and is a bigger, a smaller letter n, like, and it's read as and, or the common part. We say as common part, or we'll see logically and. So let's see one example, then you will have a clear idea. So first interval is a 1 comma 5. See, both are excluded. So second interval is 3 and 7, both are excluded. So let's write this in the number line. So first is 1 and 5. This is 1 open interval 1 and open interval 5. So this is 1 and 5. Next is 3 open interval at 3 and open interval at 7. So we are connecting these two here. Okay, so as per the definition, common values, the common values mean the two interval which values which overlapping the two intervals, or the merging section. So which is a merging section here? The values, the merging section is here, and the 3 and 5, yeah, these are the merging section. See, these are the merging section from 3 to 5. So the merging section. So this is the common, the overlapping region of two interval that we need to consider. That's called intersection part. So definition say the common region or overlap is 3 to 5. See, 3 to 5 is the overlapping region. So we need to consider 3 to 5. So how we will write a intersection b? So a intersection b is equal to, we can write 3 to 5. This is the intersection point, intersection region. Okay, so a intersection b is 3 comma 5. Let's compare with the two, union and intersection. What union do? Union do just combine, don't care about the overlapping area or common area or common part. We don't mind in the union side. We have whatever we are having in those two interval, we are just combining the both. But in come to the intersection side, what we need to consider is check which is the common area or overlapping region. Only that region we will consider. That is called intersection. Okay, these are the two main differences of union and intersection. Okay, so one more example I need to explain you in the intersection side. In this example, there is no intersection, there is no common region between these two interval. So how we will represent and how we will write it? This is how we are going to see. So first I'm just representing these intervals in the number line. The first interval is So there is no not connected. If it's a union, we can simply write A union B, we can simply write. But it's intersection. The main definition of intersection is find the common overlapping area. But there is no common overlapping area in these two, because these are two apart, two different interval in the different sides. That is not connected, no overlap or no common area. So how we will write it? So that's why we say A union A intersection B in this section. We can say it as phi. What is phi? Phi means empty set. See, this is a symbol of a phi. There is no common region, there's no common values or no common elements in these two sets. So we can say there is nothing, zero. So zero we can say as a common set. We can, for zero, instead of zero we can say phi. Phi means empty set. There is no empty set means just like this, an interval look like there is nothing here, there's nothing here, an empty bracket. Or we can say A intersection B is equal to just an empty bracket, nothing. So in a mathematical notation, we are now commonly using A intersection B. We are using an open bracket without any element. We just see phi, an empty set. So the meaning is there is no numbers common between A and B. So once again, I just want to retake this equation to in a different form. We'll solve this equation in a different form. So let me make it very simple. So when we have an equality equation like this, which having an absolute value side, for finding the set of values of x, we need to make the left hand side, we need to make this part only the x. So we need to remove this -2 and the absolute value sign. So first we are going to remove the absolute value sign. So when we remove the absolute value sign, keep in mind just x minus 2 less than or equal to 4. When we remove the absolute value sign, just make a greater than or equal, less than or equal to sign here and make. This is how we remove, this is how we open the absolute value in an inequality equation. Okay, so we have both cases, x minus 2 from -4 to 4, maybe -4 or 4. So this is how we open absolute value. So whenever we are having absolute value equation and we want to open the absolute value in an inequality equation, just do this way. So x minus 2, right hand side will be 4, just add a left hand side also with a -4. This is how we open. So in previous problem I explained how they find the both cases and compute and separately and find the values of x. So this one I am jumping directly into the inequality equation by opening the absolute value. So now again we have -2 here, so we need to eliminate -2 also. So what we do, just add -2. So in while doing any operation in this part, we need to do in both sides also. So if any side we are going to do any operation, the same thing you must do in the all sides. So if you are going to eliminate +2 here, we need to +2 here and here also. So let's see. So I am going to add x minus 2 plus 2 less than or equal to 4 plus 2. Here also the same, -4 plus 2. Okay, so here 2 and 2 eliminated. So -4 plus 2 is -2 less than or equal to, so x only left here, less than or equal to 4 plus 2 is 6. See how directly we reach this inequality equation. So this is the values of x which satisfies the above equation. So from -2, from the values including -2 to 6, the set of values, if we substitute in this equation, we will meet the values will be less than 4. Then now we need to convert this into interval notation. So interval notation is very simple, as we discussed before. When we have equation like this, we can simply write -2 comma 6. So 6 and -2 are included, so we need to write here a close bracket. So square bracket. So the both values are included. So this is the interval notation of the above mentioned inequality equation. Okay, there's some quick tips for you. See, first one, use parentheses for less than and greater than. So less than means for less than and greater than symbol. If you are having these inequalities, use this parenthesis. Parenthesis means this symbol. Okay. Then use brackets for less than or equal to and greater than or equal to. So when we having a equation, you can be having a symbol like this, we need to use this brackets. Because why? Because the numbers inside inside this brackets are included, not excluded. See, infinity always uses parenthesis. So that we already know. Minus infinity plus infinity. We need to always uses parenthesis, the open bracket. Because why? Because in infinity we cannot include. Then combine u if you have separate two parts. So if you have the separate two parts of the inequality or the interval, and to combine with union symbol. Okay, these are the 4 tips we already discussed in the previous, but just want to remind it. Okay, the another important thing is when to reverse the inequality sign. So inequality reversing means inequality sign, for this is the first inequality sign. So we need to reverse means we are reversing this in the opposite direction. This is how we reverse the sign. So when to reverse the inequality sign? See, you do not automatically reverse the sign when opening the absolute value. So when we have an absolute value, when opening the absolute value, you cannot reverse the sign automatically. You only reverse the sign if you multiply or divide. See, keep this point, not this point. If you only reverse the sign if you multiply or divide the whole inequality by a negative number. See, let's look at an example here. So x, absolute value of x less than or equal to 3. That means x might, and we need to open this absolute value. So we need to consider both cases. X might be negative, x might be positive. So but when we put in x inside the absolute value, always be positive. So if we open the absolute value, the x might be positive or negative. So we will consider the both cases. So x is positive, so positive x less than or equal to 3, or x will be negative x less than 3. So these are the two cases. So here what we see, this is positive x, this is negative x. So we need x, we need the left hand side should be x. So what to do, we need to remove this negative from the left hand side. So we need to make here x. So multiply with a negative 1. So minus 1 times x. So in the right hand side also same, minus 1. So what we do here, we multiply this whole inequality with a negative number. So here it's eligible for, here we need to reverse the sign. So here minus 1 into minus x is x, so positive x. So reversing the sign to this sign greater than. So then here 3 times minus 1, so minus 3. See how the sign reversed. Sign is reversed. So now in both cases the left hand side is x, positive x. So here x less than 3, in this case x greater than minus 3. Okay, so now we need to combine these two together. So while combining, see, we reverse the inequality sign because we multiply minus 1. So when we multiply with minus 1, so we reverse the symbol like this. So let's combine this both together. So x, but in here what is this, x is greater than 3. Here x will, so this is x is less than 3, x is less than 3, and x is greater than minus 3. So while writing the inequality equation, let's see in the number line. This is 0, this is minus 3, this is 3. So the first case, what is it, it's 3, x is less than 3, x is less than 3 inequality. Second case, x is greater than minus 3. That means not included. This minus 3 and minus 3 are not included. So this is how we open this side. So this is the common intersection area. So we just combine we can write the entire inequality like minus 3x greater than minus 3 less than 3. This is how we do it. So the x is greater than minus 3. So x is greater than minus 3 and x is less than, so x is greater than minus 3 and x is less than 3. Less than, so this is the inequality equation, final equation. So we converted so we are converting this into the interval form. So minus 3 parenthesis, because this minus 3 and 3 are not included. So this is how we solve inequality equation having absolute value. But keep in mind, when we multiplying a negative value, or when we multiply or divide with a negative value on the entire inequality equation, we need to reverse the sign. Okay. So once again, I just want to request your attention to this problem. While we computing this inequality equation, absolute value of x less than 3, we have two cases, right? We'll be opening this absolute value. We got two cases. That means x greater than minus 3 and x less than 3. These are the two cases. So just I'm marking this into the number line. Okay, so first one, x greater than or equal to minus 3. So minus 3 is not included. So I'm just opening an open circle here, and it's going towards positive infinity. Going towards positive infinity. Okay, positive infinity. Second one, x is less than 3. 3 is also not included. Okay, so it's open circle, so it's going towards negative infinity. Now I'm just making this into the interval notation. So x is greater than minus 3 means minus 3 comma infinity. Okay, for this one minus infinity comma 3. This is the interval notation of these two cases. So first, the important thing is we need to make this equation, satisfy this equation. We need to have some set of x values. See, if we put all the values in this minus infinity to the positive infinity, this equation won't be working. For example, in this case, minus 3 to positive infinity, that means we are we are taking 6 as a x value. So we are substituting this 6 in the equation. So absolute value is 6 less than or equal to 3. Is it true? No. Absolute value of 6 is greater than 3. So this is not true. So we cannot take union here. If you take union here, what happened? So this one, see, minus 3 comma infinity union minus infinity comma 3. What happened here? If you're writing in union, then the answer will be the combined interval will be minus infinity to infinity. So is it true? We can make minus infinity to infinity. You can make any numbers and substitute into this equation. You will get the answer? No, because if you substitute 6, the answer is wrong. So in this case, what we need to do is we need to consider only common intersecting region. Okay, only common intersecting region. So that's what I'm telling about intersection. We need to take an intersection. So let's see, from this range to this range, that means we need this both cases true. We don't need to make any one case true, because if it's only one case true, minus infinity, this is the infinity to minus 3, this all values we cannot substitute here. So in this case, we need to consider only the common intersecting region. For example, minus 3 to 3. If we put any values in between this minus 3 and 3, we can satisfy this equation. For example, we are putting minus 2. So minus 2, absolute minus 2 less than 3. Is it true? Because minus 2 is 2. Absolute value of minus 2 is 2. 2 less than 3. Yes, true. 2 is less than 3. Correct. For example, we are taking 1 here. So absolute value of 1 less than 3. Is it correct? Correct, yes. But that's what I'm telling. If we having an absolute value equation, when we opening, we have two cases. But in while finding the separate interval notation, you should do intersection. You should not take union. If you take union, you need to consider the entire values, and if you substitute any of the entire values from this x, no, this equation is not going to satisfy. So only consider the intersection point. Okay, this intersection point only it will work. So always keep in mind, if you have a solution, you need to go back and recheck with the original equation. Then only we can finalize the result you got is correct or not. So the final interval notation will be -3 to 3. Okay, so that's why we don't take union here. Here we are taking only intersection. So we need the common values. That's only work out to this equation. We substitute any values. We can substitute any values between -3 and 3. This equation will be satisfied. If you go for any other values from this range, the equation won't be get satisfied. Equation will not be true. Okay, let's summarize. See, inequalities show a range of values. Inequality, for example, see, -2 less than or equal to x less than or equal to 2. This is a range of values. See, the values between -2 and 2. This is a range of values. Any values between -2 and 2. So that's why we call inequality shows a range of values. Interval notation is a shorthand for the same range. So this is an inequality equation. So the interval notation also same, represent the same range, but this is a different format. That's it. Both represent the solution set of equation or inequalities. The both are interconnected. So see, from the inequality sign we can convert into interval notation. Interval notation we can convert into inequality. I hope everyone understood how to deal with inequalities and intervals. Okay.